Hello, everybody. Today, we're going to have a look at the library management system app that I made. We're going to just walk through some of the basics of it and outline the big picture, how it's working, what it's doing, and how all of these classes interact with each other. So what I have open here are the two forms, the two GUI user interfaces that the graphical user interfaces that the user is going to interact with when they open up the app. So the first thing they'll see when they open up the app is they get this login form. I know login forms typically have username and password, but for testing purposes and for the simplicity of the app, we're just using a drop-down box, which gives you the list of all the users you can log in as anyone you'd like. And then after you log in, you're sent to the user form. This is the main form that people will use to interact with the program. You see three different grid views here. These different grid views are very similar to what show up in the database tables here. So let's step back a little bit and focus on the high-level data portion of the program. So here I have on the right-hand side 4 models. These are the root classes, the base classes that more or less define the data that goes inside of each of these controls. I have the combo box control here, which uses the user class, pulls directly from a user list and populates the combo box. Same for the book class, uses this book grid view uses the book class. Then we have checked out books using library books. So these are the books that have, these are physical books. The difference between checked out books and books. This is a count of the physical copies of books that exist. If you were at a library, you'd have maybe 5 of the same book. So you would indicate, I have 5 copies of that book. Book is just general information about that book. These two tables are joined by ID. So library books uses the book list table to identify which type of book it is. Then we have checkout records. So this checkout records table uses both the library book, is joined by both the library books and the user. So the reason I'm pointing the combo box is because that's the user control that is joined with the library books. So anytime a user clicks the reserve book button here, a new checkout record will be made. And from that checkout record, we toggle a field here, is available, and then that book has been physically checked out. And you can see how it's joining with both of these tables. So that uses this checkout records model here. So that more or less covers the forms and the models classes which we've built. In the files folder here, we have the database. So here on the left, we can see the database. It's very similar to the models we just talked about, very similar to the grid views. This books table has, let's just edit the books table so we can take a quick peek at the data. So we have a little bit of information about individual books. We can take a look at checkout records. So we can see this is probably the last one we should look at. Let's look at the users table. It's a little simpler. So the users table is this drop down here. You can see the names, emails. You can see everything related to different users. Then we have library books, which uses the book ID. So this right here says which book we've checked out from the books table. And then I've just put a copy number for any time we have duplicates of the same book. We give it a new copy number, and then we say whether or not it's been checked out. Then we have the checkout records, which uses both the user table. So we look at the user table, say which user is checking out which library book. And then we throw some dates in there. So that's going on with our SQLite database on the left here. So that comes from our database file here. The test database file is what I was using to test. my buttons here when I was making modifications to my code. I didn't want to touch the main database, so I was able to just quickly jump between them. And then the book CSV was how I uploaded some of the information early on when we were building this program's databases from the beginning. So that might be a good point to segue into what the database helper file did. This file here was how we initialized some of our sample data. We created a sample, a building of the data we inserted into the books table from the CSV file. And then we also added sample data from the users table with a little loop here. Nothing too important to go over. And then we also initialized the database with creating tables. I also did it using my third-party application here, this DB browser. I was able to add tables, and this is a little bit easier to use, this SQLite DB browser, for more or less setting up the database. But you can also set it up with the database helper file. Then we have this utility static class. This is a static class which performs some of the functions that we can only do with static classes, like this extension method. And then some of the other some other static classes I built to show the power of a static class and to teach the usefulness of it. But most of our code is object oriented, so we stay out of that static class for the large majority of our code. And then here, these four classes is where these four remaining classes, the repository and the services, that's where the vast majority of the logic of the program is built. The user service is pretty simple. So the user service is what connects our user model class here to our user repository class. So this user class interacts with this form here. So we decouple, we remove the tight coupling by not setting the user class directly to the database repository. And we use polymorphism here to allow us to switch between a mock user repository and to just test the logic of the program, and also to go straight into the database. So you get to use polymorphism to jump between the two different types of interfaces built inside the user repository here. We got the mock user repository and the SQLite user repository. So we're able to jump between the two. And inside the SQLite user repository are the SQL commands that read from the database. So the user repository and the user service are a little bit simple, much simpler versions than where the vast majority of logic is built, which is the iBook repository and the library book manager. So these two really are the nuts and bolts of the program here. We have the functionality of, and I'm going to pull this up here to try and show both of these at the same time. So most of our functionality comes from these two buttons here. So we also have code that works directly with the GUI. The GUI is very basic. It calls the library book manager. Maybe I should show, we'll show that too. User form. So the logic of the GUI is mostly just focused on the controls. So single responsibility. We don't want to throw too much code into the user form. We try to pull it out into the service form. But it focuses on populating the data, and then it's going to make the calls to the library book manager to populate the data. And then it's also going to make calls to the library book manager to reserve and return books. And then these two functions down here just modify the grid view to be more relevant information. But then the vast majority of our logic is built within our program here, within our library book manager, our servicing folder. We have a few properties here which call our repositories to get the information, and then these will manage which information gets sent to the front end, to the GUI. So we have a couple of properties, and then our front end, our GUI, our form will grab these properties. So our checkout records, the library books, and our books. We also have a couple of other, this is similar to a property. It's modifying the book count and the user. So the specific user is able to, we're able to pull the information of, hey, this user has this many books checked out, because that's what our user class is doing. Our user class has some logic built into it, which our user class has some logic which says they can only borrow a certain number of books. And then we use some polymorphism, some inheritance. First, we use inheritance to define some of the rules about the different users. And then all of our calls here use just a user class. So that's where the polymorphism, depending on which user class we're using, we are able to say, okay, maybe it's a librarian user, so we use these rules, or a regular user, we'll use those rules, premium user, we'll use those rules. And then there we can reference this private field which says they've checked out this number of books. So that covers our properties and then our private field in our user class. And then here you have the initialization of our repository in our user class. And then these two functions down here perform, and this is just a little helper function. This could probably be put inside of the button itself. But these are our two button clicks. Right, so for our reserved button clicks, we have a little bit of logic here. We're using some language integrated queries, also shorthand LINQ, link, and then we were first checking if the book was already been checked out. We also check if the user has reached their borrowing limit, and if they haven't, then we are good to reserve, and then we perform our book repository SQL updates to our checkout records. And if everything works well there, so now we've gone to the book repository, so now we're doing our SQL. We have, you can see this interface has a lot of functionality built into it. We've got various ways to update the checkout records, the library books. We can get all the books. And then here we do our selects, our queries, or our select queries, our update queries, and our insert queries. And we also have our mock repository, which performs all the same user interface, or all the same interface iBook repository methods, but just simple, like return 1 for get checked out books. I prefer to use something that wouldn't be a value to show up so that I know that I'm using the right information here. So, and then once this SQL query successfully works, we should get a checkout record back. If we don't get a checkout record back, it'll be null, and then we know that our SQL query didn't work. We're using an atomic SQL transaction, so the atomic SQL transaction will fail, and then it'll send a result back that's null. But if it's not null, then we do two things. The first thing is we update our local cached information here. So this local cached checkout records list will have a new checkout record added to it. Then the grid view will refresh. And then here we also have the user on book reserved method being called, and this will update the counter. So that counter that we did up right here, our checked out books counter, that'll update our counter here. So this is everything that happens when a book is reserved. When a book is returned, a lot of the same logic is being applied, where we want to do our atomic SQL command, and then if that fails, for instance, we're checking if the book was not found. If the book's not found, we don't continue with our program. We just instantly return. But if we're able to find that book, if the user has that book checked out, meaning they aren't just trying to return a book within our application that they don't actually have checked out, is what this is looking for. But if they do have one checked out, then we call our database here. Oh, excuse me, this right here was not calling our database. That was calling this function down here. Just checking our checkout records table to see. This is another LINQ language integrated query. It's doing something similar to a SQL query, but it's using our local data, our cached data. And then it's seeing if it makes sense for that person to return that book. But then, assuming it does make sense for them to return that book, they have that book checked out, they can return it. Then we use our book repository class. We go through our SQL commands, and our SQL commands will then either return a successful transaction. So if the SQL does perform a true atomic transaction where all of the queries properly execute, if it does, then we perform very similar commands where we update our local cache, very similar to our reserve book. We update our local cache data in both our checkout record and our user. And that's high level how the library book manager works. And then in our book repository, I don't want to get into the SQL too much, but the get all books is just selecting all books from our books table. And then checkout records is counting the number of get all checked out books is counting the number of checkout records where the return date is null for that specific user. And our library books for user looks for the checkout records. So this doesn't even need to, our checkout records table, since it's joined, our checkout records is joined with the checked out books table. We don't actually need to query this information. We're able to just use the checkout records, and we're storing the library book inside of the checkout records. Then we have get all library books, which is useful for the librarian user. The librarian user wants to see all the books. So that's one of the logical applications that we've built into the program. The librarian user sees all the library books and all the checkout records. And so we also built a function, even though this function, library books for user, uses the checkout record table, the checkout record table is also per user. So you can get the library books that specific user has checked out from this table with the checkout records table, but the librarian user will be seeing all the books, and so we do need to perform a query here to pull all the books. And then our get checkout records looks for librarian user or regular user. So for librarian user, we just pull all the checkout records, and for our regular user, we check if the user is, we check for a matching user ID. So that's where it's joined with that combo box, this combo box list of users. And then checkout or reserving a book. So this creates a checkout record and then returns it back to our library book manager class. So this does, I believe, 3 different queries. We have our find if the library book is first available, update the library book table to say, okay, that book is now going to be not available, and then create a new checkout record. So we add a new row and insert into. So we have a select, an update, and an insert. That's everything inside the reserve book. And then when you return a book, we update the checkout records. We change the date on the checkout records. And then the library books table changes the is available to 1, because earlier we changed it to not available. When they return a book, then that will become available. So that's the high level logic of how the program runs. This hopefully gives you a good detailed outline of more or less how the program works. There's lots of ways to improve the program. Obviously, you would want a user on the login form. You don't want a drop-down box. And then there's lots of good improvements. Maybe making the search bar look for books that are typed into the search bar is one thing that I was aspiring to do at a later point too. But this is a good high level working with SQLite permanent persistent data. So this program can now work with long-term data. It doesn't have to create new data when you come in. You can just use that database. So this is a great end-to-end user example of building an application with a SQLite user database. Thanks for watching this video. I hope this was instructive, and I'll see you in the next one. Take care. Bye.